Hello and welcome to a screencast about how quadratic functions change. So how does our average rate of change? You see why I wrote AV there? Yeah, it's a mouthful. All right, so I'm going to pick up my pen here on this graph on the left. So I'm just going to pick some intervals and we're just going to eyeball the average rate of change. Okay, and this is totally going to be a rough eyeball, so bear with me. All right, let's go on the left side here of this parabola. So if I were to pick, let's say like this particular interval here, what could we say about the average rate of change on that interval? Well, I would say the function is decreasing, right? This line that I just connected there on my parabola is decreasing. So that must mean that my average rate of change is negative. Okay. What if we were to pick a point though, let's go from here to here, symmetric points. What if we were to pick those? What would my average rate of change be between those? Because they're symmetric, we know then that the average rate of change is going to have to be 0, right? Because the y values are at the same point. So that's going to have an average rate of change of 0. And then let's pick something over here. I told you this is going to be rough. All right. If I were to connect those two with a line, what would that line be doing? Well, I would say the line is increasing, right? So that means my average rate of change is positive. Okay, so if we think about a number line, and we always want to go from left to right on our function, which way are we going on our number line? Well, negative numbers lie over here, right? 0 lies here, and positive numbers lie here. So as I'm going on my number line, I am going left to right. So that means I am increasing. So my average rate of changes, that's a horrible English phrase, I'm sorry, are increasing. Okay, so here my AV is increasing. All right, so this is a parabola that opens up. We talked about that before. So then the A value here is greater than 0. Okay, not that that matters, but just trying to tie things in. Okay, on my other parabola, let's do kind of a similar idea here. And maybe you guys can already jump ahead of my video or pause it if you want to make sure you're thinking along the right lines. Okay, so again, if I were to take something over here on the left side, and I were to connect those, that was bad, but pretend like that actually works. Again, it's increasing, so my average rate of change is going to be positive. Pick something that's symmetric. There, my average rate of change is 0. And then pick something over here on the right side, my average rate of change is negative. Okay, so again, let's think about this on a number line. My negative numbers are here, 0's here, and this is positive here. So this time I'm going from positive to 0 to negative. Positive to 0 to negative is going this direction, right? So that means I'm actually decreasing. So because I was looking at my average rates of change, that means that my average rates of change are decreasing. And this parabola opens down, that is when A is less than 0. So this is kind of an interesting thing. So you're not necessarily looking where the function is increasing or decreasing. Actually, you're not doing that at all. You're looking, what are the average rates of change doing? Are they increasing or decreasing? So because we have a new kind of idea here, we've got some new vocabulary as well. So this is something called concavity. And if you don't get this now, we're going to be working on this a lot this semester. And you guys are going to really see this a lot in Calc 1. So don't worry if it doesn't make total sense to you right away. Definition though here, if a function f always bends upward on an interval a to b, we say that f is concave up. Okay, so bending upward, so that would be, oops, let me get rid of my pencil here so I can go back. Bending upward would be this graph over here on the left. Okay, so bending upward would look something kind of like this. So this is considered concave up, and that also means that our average rates of change are increasing. Okay. Now my interval A to B is kind of wonky here, so let's just say this is A and this is B. I don't know, just to give it something. Because obviously I don't know for sure this is going to continue on, etc., etc. Okay, similarly, if f always bends downward on an interval, a to b, we say that f is concave down on a to b. Okay, so bending down would obviously be our other parabola. So then that means it would have to go down. So this is, oh, and CC, by the way, means concave. Concave down. And then that was what we said our average rates of change are decreasing. Okay, so like I said, concave up, concave down. So with lines, these definitions didn't make any sense, right? Because of the fact that they don't change direction, okay? So that doesn't make sense there. And then with other function families we're going to study, sometimes graphs will always be concave up or always be concave down, or sometimes they'll be both, okay? So then that's why we define this concavity idea on an interval. So like I said, my graphs happen to always be concave up and always be concave down, but you can just take a chunk of the graph and it could be concave up or concave down. All right, good luck with this. And like I said, we're going to be seeing it a lot, so keep working at it. Good luck.